Good evening to all of you. I know you are all doing well. Thank you for meeting once again. And we are continuing our lesson with the caption The Meaning of Simple Machine Part 1. Simple Machine Part 1. Our objective for this lesson is that at the end of the lesson you'll be able to define simple machine, explain the properties of simple machine, and do a simple calculation on simple machine. Let's start. The meaning of machine. What is machine? As we are all familiar with, machine is any device which help us to do work. The emphasis is here, to do work more easy and more convenient. So any device that will help us to do more work more easy and conveniently is described as machine. An example, we are talking about simple machine, not a complex machine like the car engine and robot and other things. We are talking about a simple one that can help us to do work easy. An example include a claw hammer, the hammer that the carpenters use, scissors that the seamstress use, wheelbarrow, caterpillars, bottle openers, and wheel and hot axes. Let's look at some of the properties of machine. Machines have three major properties, and the first one is efficiency. When we talk about the efficiency of a machine, we say it's defined as the ratio of work output to work input as expressed in percentage. So it can be expressed as efficiency is equal to work output over work input multiplied by 100%. Or we can also use mechanical advantage over velocity ratio times 100 to express the meaning of what? Efficiency. Don't forget about these formulas. We'll be meeting them as we move along. NB. Work input is the work done by the effort. So the work you do is the same as the work input. So the energy you put into the work is what we call the energy input or work done. Then the energy you put in, the outcome of that energy is what we call the work output. So we say that the work output is also equal to the weight of the load times the vertical height. So work output is equal to weight times height. The efficiency of a machine can be increased by reducing the friction of the machine through oiling or greasing of some parts of the machine, as well as polishing the surface which is in contact. So for example, when you are rubbing your palms like this, when you are rubbing it, when you apply pomade within your palm and you rub it, it make it what? Simple and easy to overcome friction. But the moment you don't apply it, moving the palm require more hot input, and because of high friction, it affects the efficiency of the machine. So let's look at this question that they like asking. Note that efficiency of machine is usually less than 100%. Why is it less than 100%? The reason is simple. One, because some of the energy is used by the machine to overcome friction. That is why when you send maize and corn to be milled by a corn mill machine, at the end, if you check the quantity of maize you send, you see that at the end you not get the exact quantity. It will reduce because some of it has been stuck inside the machine. Then another one, because of production of heat and sound, some of the energy is used to produce heat and sound, which make the machine not to be 100% efficient. Let's look at the second property. The second property of a machine is a mechanical advantage. It can be also explained as the ratio of the load to the effort applied. So we say MA, which is mechanical advantage, is equal to load over effort. And note, it has no unit because it's a ratio. The next property, which is last, is the velocity ratio. Velocity ratio is defined as the ratio of the distance moved by the effort to the distance moved by the load. So here the emphasis is on the distance of the both sides. One, the distance of the effort you put in, as compared to the distance of the load, that is the work that is being done at the same time. So it can be expressed as VR is equal to efficiency effort distance over load distance. It also has no units because it's a ratio. So if the distance is measured in meter, effort distance measured in meter, load distance also measured in meter, the meter will cancel each other, making it unitless. So let's take one example, one calculation on how we can do a simple calculation on machine. Example 1. A student eats a bowl of rice, of which rice with 80 joules of energy. If the student make use of 50 joules of the energy in running a 100-meter race, calculate the efficiency of the student energy conserved. As I've been telling you, always when you are doing calculation, you must be concerned with your data. The data inside the question is what will help you to know how or what you should do to do the calculation. So you look at the data, you see that the energy input, a student eats a bowl, so it means that the student make use of 80 joules. You have been given 80 joules of energy of food to eat so that you can run for the school. So that is the energy input there. Then the output, to cover the 100 meter, the student use 50 joules as the output of the work, and we are to calculate for the efficiency of the student. So you can see from this question that, as we said, that no machine is 100%, because you can see that 80% was put in. By the end, we managed to get 80 joules, and then we got 50 joules. It means 30 joules is missing. So we want to express this in percentage. Therefore, the efficiency from the slide 2, energy is equal to energy output over energy input, which is 50 divided by 80 multiplied by 100 will give us 62.5%, because we have expressed it in percentage. I hope it's clear. Let's look at question number 2. A system of lever has a velocity ratio of 5. If an effort of 10 Newton overcome a load of 40 Newton, what will be the efficiency of the lever system? It's a past question. WASSCE. Our data from the question, the velocity ratio is equal to 5. The effort, energy input, effort is 10 Newton. And the load is used to overcome a load of 40 Newton. What will be the efficiency of the lever system? Remember, concerning the efficiency, we are given two equations. The first one, as we learned from the previous slide, the energy output over input times 100. This one, we are using mechanical advantage over velocity ratio times 100% because those are the data that was given to us. We were not given any output and input, but rather we're given the effort and the load. Therefore, we can use that one to do the calculation. So looking at the data there, we know that mechanical advantage is equal to load over effort. And we're giving load to be what? 40, and the effort to be what? 10. When we go down, you see that the mechanical advantage will be 40 over 10, which will give us 4. No unit because it's a ratio. Here is Newton. Then this side is also Newton. So N will cancel N. Therefore, there will be no unit left. So the answer will be what? 4. Now, after getting our mechanical advantage from the previous slide, you see that we were given the velocity ratio to be 5. Therefore, we do the substitution. 4, which is the mechanical advantage, divided by the 5 velocity ratio, multiplied by 100%, will give us 80%. 80%. I believe it's clear. Let's move on. Example 3. Example 3. This one is 3 in 1. An effort of 200 Newton. An effort of 200 Newton moves through a distance of 8 meters. So it means that the effort distance will be what? 8, because the effort is 200 Newton. It's moving through a distance of 8 meters to raise a load of 4,000 Newton. A load of 4,000 Newton, also through a distance of 4 meters. 1. We are to calculate for the mechanical advantage, velocity ratio, and the efficiency of the machine. And the efficiency of the machine. There is no E here, so take note of it. So the data, distance of effort is 8. The effort itself is 200 Newton. Load distance is 4, and the load itself is 4,000 Newton. So we take the first one. From our properties of machine, we learned that mechanical advantage is load over effort. Therefore, to be 4,000 divided by 200, which gives us 20. Take note, we said they are all in Newton. They are all in Newton. Therefore, what we'll be doing is the N will cancel the N. Therefore, no unit. So we have gotten our mechanical advantage to be 20. Then velocity ratio. Velocity ratio is effort distance over load distance, or distance of effort over distance of load. They are all the same. So we pick from the question, our effort distance is 8 divided by the load distance, which is 4, and that one also gives us what? 2. They are all in meters. Therefore, the meter M will cancel what? M. it was 8 meters and 4 meters. Therefore, the m will cancel the m and there will be no unit left, and it's a ratio, so you go through there. Then the third one, the efficiency of the machine. The efficiency, this is for the second one, and this is for the third one. Let's take note. It was a typical error. So efficiency is mechanical advantage over velocity ratio. So to be 2 divided by 2 times 100%, which will give us what? 100%. We are saying that machine, no machine is 100%. So why this one we are getting 100%? It's for the sake, because of the calculation. We just choose the figures to do the calculation that has ended up this way. There is no machine on this earth that can work 100% off for you. I believe it's clear. Now you have gotten how to do the calculation with efficiency, how to calculate for mechanical advantage, and how to calculate for velocity ratio. I know it's clear. Now it's time for you to take a try test. This one, take your time and do it for me. Question number 1 says, in a simple machine, the energy input is 120 joule. If the efficiency of the machine is 80%, calculate the energy output. The emphasis is here, energy output. So look at the formula you need that you can use to solve it. Number 2, explain the statement the efficiency of machine is 80%. When we say the efficiency of machine is 80%, what does it mean? Number 3, a lever system has velocity ratio of 4. If an effort of 100 Newton is applied to the system to raise a load of 200.0 Newton, calculate the efficiency of the system. Calculate the efficiency of the system. Calculate the efficiency of the system. And we go to the next set of questions, which is the last. Question 4. A body of weight 200 Newton is loaded onto track by a machine which lifts it vertically. If the mechanical advantage of the machine is 10, calculate the effort required for this purpose. Question 5, which is last. An effort of 100.0 Newton is applied to a machine to raise a load of 400 Newton. Determine the mechanical advantage of the machine. Thank you very much for being with me this evening. Kindly take your time and go to the question and solve them. And it's not difficult. I know you get it as you did for the last or the previous lesson. Thank you very much.